All right, well, good morning. We've had a question about interval notation, and if I could go over that as kind of a review for people or an introduction if you've never seen it before. So that's what we're going to do. So let me go ahead and share my screen here, and we'll just get busy talking about some stuff, and then we'll go from there. All right, so interval notation is just how to write down ranges of values for things like domains. And there's two pieces that we have to remember, right? There's parentheses and then there's brackets. Okay, so if I have the interval, right, from say, let's go with -3 to +3, okay? What this means is that these are all the numbers between -3 and +3 without including -3 and +3. Okay, so it does not include endpoints. Whereas if I do something like this bracket, 3 and 3. Sorry, I'm making coffee and now you can hear it. This does include the endpoints. Okay, so this interval is all the numbers between -3 and +3 without including -3 and +3. This value, this set is this interval is -3 and +3, including the endpoints. Now, there's one rule for this that we have to remember, and that's for infinity. And infinity always gets a parentheses because we can never include it, okay? That means you're treating infinity really like a number here, and not the concept that it is. So you really don't want to say, we've included this, because that kind of implies that you've been there. And quite honestly, if you've been to the end, I would, I have a teacher that used to say, could you take a picture for me? Because I don't think I'm going to get there. And you can mix and match these. Okay, we could have a negative infinity up to 3, and this would be all the negative numbers, right down to as big negative as you want to think, up to and including 3. Okay, something like this, right, would be like 0 to positive infinity. Okay, it would just be all the numbers from 0 all the way on up. Okay, so we can mix and match them, and it doesn't have to be with infinity, right? We could do something like this. We could say we want to go from 0 up to, say, 10. And that means don't include 0, but go all the way up to 10. Okay. So if we want something like, say we wanted to know what's the domain of like x minus 3. Okay. Well, if I put 3 in here, right, we have 3 minus 3, and we end up with 0. And can we, is that okay? Yeah, that's okay. We don't get not a number. If I put in 2, that's going to be a complex number. That's not going to work for us. Okay. So 3 is included. So if I ask you for the domain, I say, well, what if y equals this? I'd like to know the domain. We would say something like 3 off to infinity. Okay. Now, what if I do this? Right, and I make it a fraction. Well, now if I put 3 in here, right, we get 0, and I can't include it anymore. So the domain here would be 3 and then off to infinity as a no upper bound, right? Any number bigger than 3 will work out just fine. All right, so that's what we do for interval notation. Now here we made sure that I I wasn't picking something that was that I had to go on both sides, and this is where it gets a little confusing and quite frankly a little annoying. If we have a function like 1 over say x plus 2, well, my domain can't include 2, right? It includes everything else, but not 2. So the way we have to write this, the domain here, okay, is going to be all the numbers up to -2, and then all the numbers after -2. Okay. Quite frankly, you're going to learn other ways of doing set notation and interval notation later on. Our book that we're using for these classes does not give you the opportunity of writing down things your own way. The way I learned how to do this was here's the real numbers, And then this symbol meant set difference, so, but doesn't include -2. Okay, so all the real numbers except for that one. So again, later on, you'll have either handwritten, and in face-to-face classes, I show my students this, and it's fine if they write this. Okay, I don't have a problem. In a face-to-face class, I'm okay with you writing this. All the numbers except x equals -2, right? You don't even need the x, right? But if there's a list, that might be helpful to do that. Because to me, this internalizes that idea, and I don't have a problem with that, right? This shows me you know what you're talking about. This one, I hope you know what you're talking about, but I know a lot of students that this may or may not be a, you may or may not have hit the target with that. But we'll keep it to interval notation because that's what we're stuck with, and that's the expectation. So something like this, right? I'll do one that's easy. X squared minus 9. Well, I made an easy one, so clearly we can see that if x equals 3, x is not equal, or x, we'll do that in a minute. I don't want to do it just yet. Okay, where x is equal to -3, we're going to have a problem. So we negate those, okay, and say that's the case. Now, how do you write this in interval notation? Well, would you rather be $3 in debt or have $3 in your pocket? I'd rather be $3. I'd rather have $3 in my pocket. This is a smaller number. So we're going to go from -infinity up to -3, skip over -3, go up to +3, skip over 3, and then off to infinity. Okay, these mean unions, so we're tying these together. Okay, so it's all the numbers up to -3, skipping over the -3. Then all the numbers between -3 and +3, skipping over the 3, and then from 3 off to infinity. Okay, the more numbers you have down here, the more of this you're going to have to deal with. Okay, and I'm sorry, that's the case, and that's interval notation, and you could say that doesn't seem very efficient. I'm the first one to agree with you, which is why in a face-to-face class, I will show my students this and say, there, you're done. Again, we don't have that option. We have to go through and do all of this. Okay, so I hope that helps with interval notation a little bit. That really is all the way, that really is all there is to it. I'll give you one more thing for, like, some people have a little bit of trouble, like, is this includes or is this not includes? And back when I was a youth, right, we play softball, we play baseball, we play stuff like that. And I always think about it this way, or soccer, right? This will work for soccer. If you're trying to kick a ball on a gate that looks something like that, right? This is your vertical scale. If you're going to kick balls into this, you're going to hit the backstop, and the balls are just kind of roll and get caught here on the bottom. So when I'm thinking about this visual of hitting balls into a backstop or into a net, they're collecting here. So these are included in the set. Okay. Whereas if you have a backstop or something that looks like that, well, you're going to hit the backstop and they're just going to roll and not quite get there. Okay, so you're just going to roll and not be included. You have to go pick these up when you're dealing with everything. So the fact that you're throwing these against the face and they're just kind of rolling off, this does not include the endpoint because it rolled away. Whereas this does include the endpoint because I kick 3 into this backstop, it hits here and then gets stuck at the bottom here. Where if I kick 3 into that backstop, well, it just rolls away. It doesn't quite make there. Okay, and of course, if you have a kid on the soccer, that would have been me, by the way, the kid on the soccer team that kicks the ball and it just kind of doesn't quite make it, then we only care about the end point here. We're not caring about, like, here's 3, right? It rolls away, it doesn't get caught. But here's 2, it's like, well, the ball just dribbled up and stopped, and the goalie has a very easy time of not having to deal with that. Okay, so I only say that because I was that kid that would kick the ball and it would just kind of, unceremoniously stop before the backstop. All right. So, but that's just how I think about it. That might have, a visual might help you, it might not, but whatever works, right? All right. So thank you very much and for the question, and let me know if we could do more of these. All right.